Question 1. So we are given with the table here, and we have a random variable x, a discrete random variable, and for each outcome of the variable we have a given probability. So for example, here we have the outcome of 1, the probability for it is 0.2, and for the outcome 2, the probability is 0.3, and so on. Here for the outcome of 3, the probability is k, and in A we have to find the value of k. So for that I can say that when a random variable is given, the sum of all the probabilities for all the outcomes should be 1. So I can write down the sum of all probabilities, 0.2 plus 0.3 plus k plus 0.1, and this should be equal 1. This is an equation with k as a variable, and I solve and I get that k equal 0.4. So this is the answer for A. Now I move on to B. We have to find the probability that our variable is larger than 1.5. Yeah, so for that I simply sum all the probabilities of an outcome that is larger than 1.5. So we have the probability of being 2 and the probability of being 3 and the probability, plus the probability of having the value of 4. This is the probability for x to be greater than 1.5, and I simply plug in all the probabilities that are given in the table. Here this is 0.3, here it's k and the value is 0.4, and for an outcome of 4 the probability is 0.1, and we get 0.8. This is the answer for B. Moving on to C, we have to find the expected value of x. So now the expected value of x is what we need to find. The expected value is like the mean, and there is a formula for the expected value. We have to take an outcome of a certain outcome and multiply it by the probability for this outcome. I call an outcome, a certain outcome, xi, and then I want to sum over I. So what do I mean by that? I simply take the first value of x times the probability for the first value of x, and then the second value of x times the probability to have that second value of x, and so on. We have here 4 values for outcome of x. So actually they just have 2 more. So the third outcome for x times the probability for that outcome, and the fourth value of x times the probability for that outcome. And I just go to the table and I plug in all the values. So we had a value of 1 with a probability of 0.2, and then we had a value of 2 with a probability of 0.3. Then we had a value of 3 with a probability of k, which we calculated to be 0.4, and then we add a value for x of 4, and the probability for that is 0.1. So I move on, I get 0.2 plus 0.6 plus 1.2 plus 0.4, and here I get 1, 2.2, 2.4. So this is the expected value, and this is the answer to C.